all for coming, and I appreciate you all giving up some of your Saturday to come here. I'm really excited this morning because we have two prosthetists from Hanger Clinic here today, and they brought a lot of examples for you to look at. You're going to get to touch them and try them, and I'm really excited. And we have Christina and Robin has been practicing for like 14 years in this field. Christina is new. She also has a degree in mechanical engineering. She's going to talk a little bit about what it takes to become a prosthetist, what kind of training that she just went through, and then they'll talk a little bit about what they do, and they have all these great things. So come on up, ladies. Thank you for coming.
So I'm Robin, and this is Christina. Christina's going to talk about the process of getting to be at our point in our career, and then we'll go over some of these cool tools out here.
So actually the timing of this is really interesting because I just took my certification exam, so I am just now a certified prosthetist. So as of like last week, the process is fresh in my head. And so my background, I actually went to undergrad in mechanical engineering, and I chose that because I liked working with I liked math and science and problem solving, and so I took that track. And then after that, I was ready to get a job. 4 years of college, I wanted to make money and get into the industry, and so I got a job in actually the power industry, and I worked as a mechanical engineer in that for a couple of years. And I liked it, but I always really wanted to work with people and patients, and so I was trying to figure out how I could combine that want to see patients and work on kind of a micro versus a macro level, so really help one person at a time and to meet their goals versus making something that would help thousands of people, but you're not really working one-on-one with someone. So that's how I decided to go into prosthetics. The prosthetic degree is a 2-year after undergrad. There's 2 years, one in so prosthetics. It's 1 year prosthetics and 1 year in orthotics. And orthotics is, everyone thinks of foot orthotics, but it's actually bracing of any part of your body. So people that need scoliosis bracing, people that have stroke, that need help picking up their feet, the little babies that need the cranial helmets, that type of thing. And then 1 year prosthetics, which is learning how to design and create the artificial limbs. And then after that, there's a 2-year residency, so 1 year in prosthetics and 1 year in orthotics. And then you take a certification exam, which is 2 written tests and 1 oral exam, where they ask you to complete tasks and test your problem-solving ability and hand skills. So what does a typical day look like for a prosthetist? We're trying to help a patient meet their mobility needs. So we'll meet with a patient, and first we kind of talk to them and evaluate them, find out what their struggles are and what they're trying to accomplish with their limbs. So things that we think about are what they're doing for work, whether they're working with heavy machinery, they have a job where cosmesis is really important, or what kind of sports they're into, those type of things. Once we get an idea of the tasks that they're trying to accomplish, then we start looking at what's their range of motion, what's their strength, have they had an amputation, or were they born with maybe a missing bone or some sort of different anatomy that we need to account for. And then from there, once we have an idea of a plan of what we're going to do, we cast the residual limb, and that way we have a model of the patient's limb to work with. So we just wrap it with a fiberglass, as if someone were to break their arm. We just wrap it and mark bones and different landmarks in order to create this socket that the patient's going to put their hand in, that's going to apply pressure to places that the body can tolerate pressure, and relieve bony areas where it would hurt if the patient had pressure on that area. From there, we fill that model with plaster, and we end up with a little plaster model of the patient's limb. that, we take plaster away and add plaster in places that we don't want them to get pressure. If that makes sense. And then from that, clear plastic is pulled over this model, and so we end up with a clear plastic socket like this, although it's clear, so we can try it on the patient and see how the fit is. So it's clear and put over the top, and we ask them to do different movements to see how it's fitting, and then from there, if we're satisfied, then it gets laminated and turns into a more definitive socket. So that's kind of the overview of how the process works.
So when she's talking about this process, this would be considered a socket. So this is a pretty short transradial. Their limb ends here. So this would be the socket portion. The socket is the actual piece that the limb actually fits into. And there's lots of different ways that these are suspended. Some of them are suspended by anatomical pressure. So they'll be able to rotate their limb inside of here, and it kind of locks in over the epicondyles, which are the bones on the outside of the elbow. Other ways are held on by a harness system. A harness system for body-powered prostheses are controlled by muscle and movements. That's what we brought most of. They're the most functional with the most simple components. So there are some up here. These two are actually for able-bodied people to try. So you guys can come up here and work with these. As far as us choosing the components, we have two terminal devices. One is considered a voluntary closing, which is this one, and then the other is considered a voluntary opening, which is this one. And they're both operated by cables. This voluntary closing is for someone that has a lot of muscle control and needs more pinch force than what these little rubber bands will hold. The rubber bands are a pound of pressure per band. So you'll find some people that do a lot of heavy duty work will have 10 bands on them just to apply more pressure to the object that they're trying to hold. And as far as the voluntary closing, they're going to be able to apply however much pressure they can force with their muscles.
So one of the disadvantages and advantages of the voluntary opening versus voluntary closing is that the voluntary closing, you can apply however much pressure you want. So say if you're picking up a Coke can, you can squeeze it very lightly and then and not just crush the whole can. But it takes muscle strength that whole time because you're having to hold the whole time versus the voluntary opening where you use your muscles to open it, and then when you release, it closes, and so you don't have to use any strength once it's closed. So if you're holding something for a long period of time, you want the voluntary opening.
You can rotate around and come up here and try these. We can put these on. We can show you how they go on so you have a little easier idea. So this is all controlled by the placement of the harness on the back here. And what is the motion that controls it? Scapular abduction.
Yeah.
So it's coming along the lower portion of your scapula. And as you curl your back, it's going to operate the terminal device.
So you're using the shoulder for this.
And that's for both of these. This one has a triceps cuff. So this is more for a heavy duty user that's going to be lifting heavier loads. The triceps cuff goes through the back here. This one's a little more difficult to put on. So it disperses a lot more of the load here. And depending on how the prosthesis is suspended, they can carry a 5-pail bucket, and the strap and harnessing is going to be what is supporting the load. So they're not really supporting the load through their line.
Can I take a clarifying question? We wouldn't be allowed to do that, correct?
A tricep cuff is fine.
Because we had one group that had it removed from their device, but they were allowed to compete last year.
Were they
Like
using the
that.
device? Were they using that to open and close it?
No, but the wires were running through it, so it was helping to support where the. So yes, but
Let's-
not
Let me double check on that.
Okay.
And if you have a picture of the device, I'd like to see it.
not with me.
We will remind me, and I'll get back to you on that.
Sorry.
And outside of the body-powered conventional prosthesis, so this is also a conventional body-powered prosthesis, but it has more of a cosmetic hand. This would be more for someone that doesn't really want to have fine motor skills with the terminal device because it's adding bulk, but they do have a little bit more of a cosmetic appearance to them. So you might find someone using this that works in a bank or something like that that needs to have that appearance there. And it's, it's pretty bulky and it just doesn't have that fine motor ability. Outside of the conventional, we have a passive device. They can pick up, use it, just using it as an assistive device and more cosmetic appearance. Then you have the more mechanical, which is the myoelectric prosthesis, and it is functioned by muscle contractions. And there's little electrodes inside of the socket that we find good placement for. So as they contract the muscles, it opens and closes. I think that this one is charged. So you might be able to. Anyways, so that's controlled by electronics. And this is also for a myoelectric prosthesis, and this is usually used by mechanics that have to hold strong and durable equipment. And it has a little tiny hook for little fine motor skills, and then it has a lot of strength and rotation. So if they're having to change oil cans or oil filters, they're able to grab it and actually rotate it by the electronic rotator. Any questions?